Good morning, students. Here, Professor Surendran. I want to describe some of the terms which are used in the mechanism and machines. So, first of all, mechanism. What do you mean by mechanism? Mechanism is the 4-bar chain in which one link is fixed. Mechanism is the chain, kinematic chain, in which one link is fixed. The input motion is given to the any other link, and to get the desired output motion. So that is the mechanism. So it is used to transmit or modify the motion, transmit and modify the motion. So that is the basic principles of the mechanism. So the next thing is machine. What is the difference between mechanism and machine? And machine is used to transmit the force. It is a transmit the force. So a machine is a mechanism in a combination of, it is a combination of mechanism. So my mechanism for a particular mechanism is prescribe the certain functions. Machine, it is a combination of mechanism which transmit the force, where energy is transmitted, the available mechanical energy is transmitted to produce some other work. Next, we are going to know about the types of the constrained motion. Completely constrained motion, successfully constrained motion, and incompletely constrained motion. So completely constrained motion means when motion between the two elements of the pair in definite direction, irrespective of the direction of force applied. So here the input force may be applied in any direction, but the output motion obtained, output motion achieved is, it should be in the particular direction. That is the thing you should know. And successfully constrained motion, the motion between the two pair is possible, is more than in one direction, but it is made into definite direction by some external means. So initially the output motion may be take place in more than one direction, but what we are doing, we are applying some external means, external force to get the desired direction. So here we should know, next thing is incomplete constrained motion. The incomplete constrained motion, the output motion, it should be in the more than one direction. It depends on the direction of force applied. It depends on the direction of the force applied. So for these three things, we are having the example. So for completely constrained motion, it is the cylinder rotated in a shaft with collar. On the two ends, the shaft is fixed with collar and it is able to rotate. So it is possible only in rotation. For successfully constrained motion, the footstep bearing should be maintain the position because of this vertical load that is acting on the footstep bearing. Incompletely constrained motion, the shaft without collar, it can able to rotate as well as translate. So these are the three different motion you can commonly observed. The first one is completely constrained motion. The second one is successfully constrained motion. The third one is incompletely constrained motion. Next, we should know about the rigid body and resistant body. Rigid body is, it does not suffer any distortion. So when a body is there, when we give the force, it does not make distorted. That is a rigid body. The resistant body, those body which are rigid for the purpose have to serve. And for example, belt drive, belt is rigid when subjected to tensile force. Belt is rigid when it is subject to tensile force. Link is a member in a mechanism. Connecting the member having motion relative to them. So link is a member having relative motion. So you can see this is the binary link, this is the ternary link, and this one is the quaternary link. In binary link, which is connected to two other link. In ternary link, it can be able to connect three other link. In the quaternary link, it can be connected to four other links. So classification of kinematic pair. So based on the nature of contact, we can classify the kinematic pair as lower pair, higher pair, and a closed pair. Lower pair means which is having the surface contact, that the two links are connected and which is having surface contact is termed as lower pair. Two links are connected which may have point contact or line contact is termed as higher pair. So the in higher pair, shaft rotating in bearing is example for the lower pair. Nut turning on the screw is example for the lower pair. So all pair on the sliding crank mechanism is the lower pair. Higher pair. Next, we should know about the higher pair. Higher pair, which is having the point contact or line contact. So rolling in a surface, a roller rolling in a surface has the line contact. Cam and follower. So based on the follower, it may be line contact or point contact. So according to the nature of the mechanical constraint, so it can be named as a closed pair or open pair. When the element of pair held mechanically, it is known as closed pair. The contact between the two can be drawn by destruction of at least one of the member. So this is the open pair. So all lower pairs are closed pair. All lower pairs are closed pair. All lower pairs are closed pair. Open pair also called as unclosed pair. When two link of pair are in contact either due to force or gravity, force of gravity or external spring action, it is called as open pair. According to the nature of relating motion, it can be denoted as sliding pair. If two links have sliding motion, it is called a sliding pair. So rectangular rod in a rectangular hole in a prism. So in a rectangular hole, only rectangular rod can be passed. So that is the sliding pair. Turning pair, when one link is turn or revolve. So two links are connected by the pin joint, it can revolve like this. So that is the turning pair. Rolling pair, one link roll over another. The belt is roll over the pulley. Screw pair, screw pair is also called as helical pair. Screw pair is also called as helical pair. If two links have turning as well as sliding motion between them, form a screw pair. Turning as well as sliding motion. In turning motion, only turning action take place, turning pair. In sliding pair, only sliding action take place. But in the screw pair, both the turning and sliding action take place. Spherical pair, the pair which is able to make 360-degree revolutions is called as spherical pair. Next, we are going to know about the types of joint. First one is binary joint. If two links are joined in the same connection, it is called as, if two links are connected by the same binary joint. Next, ternary joint. Three links are point joint in a connection. So it is called ternary joint. One ternary joint is equal to two binary joint. And quaternary joint is the connection of four links together at a joint. So if n number of links are connected at a joint, it is equivalent to the n-1 binary joint. So if n number of links are connected, for example, 3 links are connected, so it is equal to 2 binary joint. So that is the thumb rule. Next is degree of freedom. The connection of link with another imposes certain constraint. When one link is there, it can rotate in 3 directions and it can translate in 3 directions. So 3 translation, 3 rotation is possible. But when it is connected to some other link, the motion is constrained. So the degree of freedom is the number of independent coordinates it can be moved. Number of independent motion it can be prescribed. That is the degree of freedom. Degree of freedom equal to 6 minus number of restraint. So it is a formula for the number of restraints can never be 0. Number of restraints can never be 0. Number of restraints can never be 6. So joint disconnected. When the number of restraints is 0, joint disconnected. Number of restraints 6 means joint become rigid. Number of restraints is 6 means joint become rigid. Number of restraints 0 means joint is disconnected. So it never be 0, never be 6. So next is we are going to discuss about the spatial mechanisms or space mechanism. That is equal to F equal to 6 into n-1. This is L is given. Instead of L, we can use n also. It is the number of links. 6 into n-1 minus 3p 5p1 minus 4p2 minus 3p3 minus 2p4 minus p5. So it is F is the degree of freedom, and n instead of L you can use n. N is the number of links, total number of links. P1 is the number of joint having 1 degree of freedom. Number of pair having 1 degree of freedom. Similarly, number of pair having 2 degree of freedom, number of pair having 3 degree of freedom, number of pair having 4 degree of freedom, number of pair having 5 degree of freedom. So when it is reduced, this spatial mechanism is reduced. F equal to 3 into n minus 1 minus 2j1 minus h, or F equal to 3 into n minus 1 minus 2j minus h. That is a Kutzbach criterion. Kutzbach criterion. This equation is called as Kutzbach criterion. F equal to 3 into L minus 1 minus 2j minus h. So number of binary joint j, h is the number of higher joint. Grubler is used. Grubler criterion is used for only planar degree mechanism. So with 1 degree of freedom, only lower pair. So the equation is reduced 3n minus 2j minus 4. So it is here L is notated, but I always use n. N is the number of links. When f equal to 0, it is called as frame. When f is less than 0, it is called redundant frame. When f greater than 0, it is called constrained or unconstrained frame. F is greater than 0, it is constrained or unconstrained frame. When f is less than 0, it is called a deficient frame. All mechanism has minimum 4 number of links. Thank you, champions.